So in today's class, we are going to solve signal and system previous year questions. These questions were asked in GATE Electrical 2024 paper. First of all, I will give you all the questions so that you can try by yourself, and then you look at my solutions with tricks and techniques. First question in front of a screen. Very easy question. Pause the video, try by yourself. Then go to the next question. Again, easy question. The topic is Laplace transform. Pause the video, try by yourself. There is no need to write anything. See, mark the answer. Now this is a moderate level question. Calculations are involved but not very tough. This is a tough question, so think on it. This is easy question, not that tough. Moderate level calculation. This is a tough question. Now this is easy question because similar questions we have done in the practice courses, previous year papers. Okay, so not that tough, and that's all. All these questions were asked in electrical paper. Now let us see the solutions one by one. Very first question. Suppose signal y of t is obtained by the time reversal of signal x of t, that is y of t is equal to x of minus t, where t is going from minus infinity to plus infinity. Which one of the following option is always true for the convolution of x of t and y of t? A, B, C or D? Correct answer is option A. You know why? Because they are saying you have to comment on what? Convolution of x of t and y of t. See carefully. We have to comment on a signal, let us say z of t, which is what? X of t convolved with y of t. But what was y of t as per the question? Y of t is nothing but x of minus t. So this is your z of t. If I replace t with minus t, what will happen? In that case, z of minus t would be equal to x of minus t convolved with x of minus t, right? Where t you have replaced with minus t, this is what you are going to get as the calculation. So if I simplify it, can I say z of minus t is nothing but x of minus t convolved with x of t, and in convolution a convolved with b, b convolved with a, both are same to same. Therefore, can I say this is nothing but x of t convolved with x of minus t? Just taking this here and this player here. If yes, then this thing is what? This thing is z of t. If that thing is z of t, therefore the conclusion is z of minus t is equal to z of t. This implies the given signal is what? This is even signal. So even signal is the answer, and hence you can see that option A is correct. Okay. Now this is method 1 to solve a question. There are multiple ways to solve the question. This is one of the method, and I was like, the question is very easy. See this line itself, I knew the answer. By seeing this line, I knew the answer. You know why? Because x of t convolved with x of minus t. This is what? This is autocorrelation function. So if this is autocorrelation, what is the property of autocorrelation signals? That signals are always even. Okay, they are always even, and because it was autocorrelation, we know the property, it is even. So see the option, mark option A, and that's all. The correct answer is option A. No need to do all the calculation. Okay, so that was your method 2. Now let us go to the next question. If u of t is the unit step function, then the region of convergence ROC of the Laplace transform of the signal is what? A, B, C or D? The correct answer is option A. You know why? Because looking at the signal, what do you get the feeling? Is it a finite or infinite signal? Sarji, it works in this range. Okay, so this u of t minus 1 minus of u of t minus 10 will give us a finite signal, right? This calculation gives us the idea that x of t would be what? It would be a finite signal. If it is a finite duration signal, in that case ROC is entire S plane. So ROC will be entire is or will be. Okay, so ROC will be entire S plane. So therefore the correct answer is RE of S is greater than minus infinity and less than infinity, because the given signal was a finite duration signal. Understood? Very basic concept, very basic question. Let us move forward for the next question. Let x of omega be the ft of the signal, which is Fourier transform, and signal is given like this. The value of derivative of x of omega at omega is 0 is dash, rounded off to 1 decimal place. So the correct answer is what? Let us see step by step. So the very first step is, given signal is what? X of t, which is equal to e to the power minus t to the power 4 cos t. And you should know, in the Fourier transform, x of t, if I take Fourier transform of that, it becomes capital X of omega. If I multiply with the t, what happens in the Fourier transform? Differentiation. So j into dx by d omega. This is what it happens, right? Now they need what? They need derivative of x at omega is 0. So derivative of x, this player they need. So if they need that player, let us divide by j on both the side. If I divide by j on both the side, therefore can I say that dx by d omega is nothing but what? It is nothing but t x of t divided by j. This is what our dx by d omega looks like. Now, if you see carefully, it gives you a feeling, this is a time domain signal, which is f of t, right? And this is Fourier transform signal, which is what? Which is capital X of omega. If this is the time, then respective Fourier transform is capital X of omega, correct? So if that is the case, looking at this expression, can I say, as per the question, they needed dx by d omega at omega equal to 0. What we needed? Dx by d omega at omega equal to 0. So as per our notation, it is what? Capital F of omega, where omega is 0, and this is what? This is nothing but area under curve. Area under which curve? Area under f of t. So that is nothing but integral minus infinity to infinity f of t dt. So that is what now? Let us do the calculation in the further slide. Oops, we do not have any further slide. So I have to do cut paste to get the answer. Now see carefully. This is what we are going to solve, where f of t is this thing, right? So do the substitution. This is our answer, right? This is our answer. If we do the substitution, it is integral minus infinity to infinity, and then we have what? We have t by j x of t dt. And what was our x of t? So integral minus infinity to infinity t by j, and then x of t was e to the power minus t to the power 4 cos t dt. If you see carefully, we can use the property of integration to solve this question. So definite integral property says, whenever you have minus a to a as the limit, check your function whether it is even or odd. If the function is odd, integration is 0. If the function is even, then 2 times integral 0 to a f of t dt. This is how you solve. So I was like, okay, let us check this function whether this is even or odd. So if t replaced with minus t, this is minus t. Here if t replaced with minus t, same term as it is. If here t replaced with minus t, so cos of minus t is cos t only. So if you see carefully, then this was your original function, and if t is replaced with minus t, this is what you are going to get, a minus outside. This means your function is odd. Whenever f of minus t becomes equal to minus f of t, which happened here, right? So when we replace t with minus t, we are in search of f of minus t. This is what we got, which is nothing but minus f of t kind of format, right? So here the given signal was odd signal. So if the given signal is odd signal, this is how you see verbally, this is odd, therefore the integration answer is 0. Understood why the integration answer is 0? Let us go to the next question. The input x of t and the output y of t of a system are related as like this, then a, b, c or d. A tough question, right? Because linear, non-linear, causal, non-causal, we have to check a lot of things. So the correct answer is option B. Let us see why. So starting with the linear, non-linear solution. Step number 1, to check whether linear or non-linear, if the input is x1, the respective output is y1, and the things would look like e to the power minus t, integral minus infinity to t, then we have e to the power tau x1 of tau d tau, correct? if the input is x2, then the output is y2, and same to same copy you have to do. Okay, same to same copy. Instead of x1 of tau, it would be what? It would be x2 of tau. That's it. Okay, it would be x2 of tau. Now if my input is x1, okay, first let me write my general y dash term. Y dash term is what? Y1 plus y2. Then I will compare with the y double dash. So y dash is not the derivative of y, it's just the notation that y dash is our addition of y1 plus y2, right? So if that is the case, if I add them, e to the power minus t is outside, integral minus infinity to t, e to the power tau x1 of tau d tau is added with integral minus infinity to t, e to the power tau x2 of tau d tau. This is what the things are going to look like, right? Now if my input is x1 plus x2, then in that case what is my y double dash? So in that case, Sarji, e to the power minus t, integral minus infinity to t, then e to the power tau, input is now x1 of tau plus x2 of tau, and then this is d tau. So smart students can conclude here only, seeing y dash of t and then y double dash of t, both of them are same. This is how smart student knew it. But if you are not that smart, then you have to do one more step, that is splitting of integration. This thing can be said as integral will go to this function and then integral will go to that function, right? So e to the power minus t outside, integral minus infinity to t. Okay, let me write in the same format. This is how the things would look like. Okay, if you do the expansion, this is how the things would look like. Check it out. Are you getting the point? This thing multiplied with here and then multiplied with here. So e to the power minus t would be for both. Then integral for him, you can see integration 2 times, and you can say that yes, Sarji, that y double dash and y dash, they are same to same. Therefore whenever y dash and y double dash are same to same, we have seen in the practice course earlier also, then the systems are linear system. Okay, this is how I have proven the system is a linear system. So option A is wrong, and then B, C, if I check time variant invariant, I can get the idea whether B or C is correct, or if both of them is wrong, then D would be correct. That's how the things would look like, right? So if I check now time variant or invariant, so for that we have delay and replace logic, again solved in the practice course already, that this is my technique to solve this kind of questions. First I will do replace, that wherever t is there, replace with t minus t naught. Okay, so replacement if I do, then my y1 becomes what? E to the power minus t, which is changed as t minus t naught, and then integral minus infinity to t, where t is changed as t minus t naught, because replacement means wherever t is there, replace with t minus t naught. Then e to the power tau x of tau d tau. This is how my y1 looks like. Now do the delay. So delay happens to whom? Delay happens to input only. So in that case, so who is my input? So e to the power minus t is not my input, minus infinity to t is not my input, e to the power tau is not my input, x of tau was my input. So that would be delayed with a t naught. Okay, now both of them same or not? Some students will say, sir, they are not same. This means you have not checked properly. X of tau here it is not x of tau, so make them same. If I have to make this as x of tau, what should I do? So for that you have to replace tau minus t naught is k. Okay, so if I do that, differentiate on both the side, then d tau changes to what? Dk. Also change the limits. Okay, so to change the limit, first see tau limits minus infinity and t, then see who is the new variable. K is the new variable. So if I place infinity instead of tau, minus infinity, the answer is minus infinity only. But if I place t, then k becomes t minus t naught. Okay, now change your y2 and see how the integration looks like. So y2 is equal to, first let me copy that so that you can see what things I am going to change. Wherever tau is present, it would be changed, right? See carefully. First of all, wherever tau is there, those players would be changed, and also integration limits would be changed, right? Therefore, I can say e to the power minus t is unchanged, limits are changed because k is going from minus infinity to t minus t naught, right? Then e to the power tau is what? If t minus t naught is k, then tau is k plus t naught. So k plus t naught. This is what the things are looking like. Now what's next? X of tau minus t naught is k and d tau is dk, right? I can split this player, e to the power minus t integral minus infinity t minus t naught, right? And then I have e to the power k e to the power t naught x of k dk. Okay, what's next? What's next, Sarji? You can take this player outside. Yes, because that is a constant. K are the variables, those cannot be taken outside. So if I take this player outside, can I club the powers and can I say e to the power minus t naught, and then I have integral minus infinity to t minus t naught, then e to the power k x of k dk. This is how the things are looking like. So if I replace, check it out, now comes the integration property. See carefully, change of variable property, that if k limits are this thing, function is in terms of k and then it is dk, you can replace k with tau, still the integration would remain same. How come? You only check integral 0 to 1 x cube dx, is it equal to integral 0 to 1 tau cube t tau? If yes, then same property I have used. Okay, same property I have used, just change of variable property. So change of variable property will give me my y2 is equal to e to the power minus t naught integral tau is going from minus infinity to t minus t naught e to the power tau x of tau d tau. Then you will say, oh Sarji, this same thing is our y1 also, same to same. Check it out, same to same. If you got same to same, this is what then? y1 is equal to y2, means we are in a time invariant. They are not varying with a time, they are time invariant. This is our conclusion. So time invariant, and we had a linear system. This is our conclusion. So basically this is LTI system, linear time invariant system. So hence option B is correct. But this is method 1 to get the answer, and I know a lot of student will say, sir, this is a topper's question, very tough, see how much time it requires because all the calculation and stuff. Okay, so you might think in that way, but I do not think in that way, because I know that I can solve this question in one line because I have method 2. Our question was y of t is equal to integral minus infinity to t, e to the power minus t was outside. Okay, let me first copy, otherwise you will say क्या लिख रहे हो आप, हमको कुछ समझ नहीं आ रहा. Okay, so let me write as per the given data first, and then let me do my manipulation in the next slide. Okay, so if I take this player inside and I club the powers of exponential, this is what the things would look like. Minus is outside, t minus tau would be inside, x of tau and then d tau. Correct? If that is the case, don't you feel it gives us the feeling of what? Convolution between the two signal. Yes or no? The standard definition of convolution, that here this player gives us the idea. Let me write in this way. This exponential player gives us the idea about the h of t. Okay, so h of t is what? E to the power minus t u of t. E to the power minus t u of t. This player gives us the idea of what? X of t, input signal. So it's nothing but convolution between x of t and h of t. Okay, so if it is convolution, convolution happens in which system? Convolution is possible. Convolution is possible only in LTI systems. So this system was linear and time invariant system. So just by taking this player inside, clubbing the exponential power, looking at this stuff, it's x of t converted with h of t. So this is where I got the idea of x of t, and this is where I got the idea of the convolution, right? So it was e to the power minus t u of t, right? So in that way, convolution happens only in LTI system. The answer was LTI, linear and time invariant. Easy. So no need to do all these things. Just look at the question, mark the answer. If you know the tricks and techniques, let us move forward for the next question. Consider the DT system, discrete time system, T1 and T2 defined as follows. So you can see that which one of the following statement is true. This is what they are asking, Bebo stable concept.